Next thing we're going to look at is writing word equations and then balancing those equations. So a word equation tells you everything that's reacting and being produced in it. It could say reacts with, produces, or it could say yields instead of produce, but it tells you everything that's going on. So you just basically have to write down the equation like it says, then you go back and check the charges and then balance it. So we're going to start out with the first one. So it says barium chloride. So we know barium is Ba and chloride is just chlorine. So we're going to write the Cl. Reacts with is your plus. Sodium is Na. Sulfate is a polyatomic ion. So we're going to look on here. Sulfate is SO4. And it says to produce sodium chloride. So sodium is Na. Chloride is just chlorine. And barium sulfate. So we know barium is Ba. We already looked up sulfate, so it's SO4. So that's like a skeletal equation. We've got everything written down. Now we have to go check the charges of everything to see if it needs subscripts. So we're going to look at the charge of barium. Barium is in the second column. So it has a positive 2 charge. Chlorine is in group 17. Those all have a negative 1 charge. Sodium is in the first column. So it has a positive 1 charge. Everything in that column has positive 1 charge. Sulfate is one you have to look up from your reference table. So sulfate is SO4 with a negative 2 charge. Now we can just transfer their charges over here. We know sodium is positive 1, chlorine is negative 1, barium is positive 2, and sulfate we said was negative 2. All right, if you have a positive 2 and a negative 1, you need 2 negative 1s to balance that out. So you're going to need a subscript of 2 there to show that we needed 2 chlorines to balance that out. Sodium is positive 1, sulfate is negative 2, so we needed 2 sodiums to balance that out. Then we've got NaCl, positive 1, negative 1, they're already balanced out. Barium, positive 2, sulfate, negative 2, those are already balanced out. I'm going to go ahead and erase these charges. You do not show those in a chemical equation. Those are just to help you find out what the subscripts are. So the equation's correctly written out. We got all the subscripts where they need to go. Now we're just going to go back and make sure it's balanced. So we have 2 sodium here and 1 here. So we're going to put a 2 coefficient in front of that. That changed sodium to 2. It also changed chlorine to 2. And we have 2 there. 1 barium, 1 barium, 1 sulfate, 1 sulfate. So it's balanced. And let's go ahead and classify barium chloride, sodium sulfate. So you have compounds, 2 compounds that have 2 things in them. So barium chloride, sodium sulfate. They just switched endings. So that is a double replacement reaction. Let's look at the next one. It says magnesium, Mg. Bromide is just bromine, which is Br. Reacts with potassium hydroxide. Potassium is K. Hydroxide is your polyatomic ion that you have that ends in IDE. And it is OH with a negative 1 charge. I'm going to go ahead and show that negative 1 charge since we just looked it up. Reacts with potassium oxide to produce potassium bromide. So that would be KBr and magnesium hydroxide. So that's the OH. So now we just have to check the charges. Magnesium is in the second column. It has a positive 2 charge. Bromine is in column 17. All of those have a negative 1 charge. Potassium is in the first column. That has a negative 1 charge. So we can go ahead and write those over here now. I'm sorry, potassium was in the first column. It has a positive 1. I can't remember if it's a positive or negative. Magnesium is a positive 2, and hydroxide is negative 1. All right, so we have positive 2, negative 1. So we need 2 of these to balance it out. So we're going to put a 2 subscript. And we got K Positive 1, OH, negative 1, those are already balanced out. Positive 1, negative 1, those are already balanced out. Then we have a negative 2 and or a positive 2 and a negative 1. So we need 2 hydroxides. Anytime you need more than one polyatomic ion, you put it in parentheses and put a 2 out from it. So that means we have 2 hydroxides. Let's erase these charges. You don't show those in your final equation. Now we're going to go back and balance it. So we have 2 hydroxides here and we have 1 over here. So we're going to put a 2 in front of that. That changed potassium to 2. So we're going to put a 2 in front of this. That changed bromine to 2, and bromine's already 2 over here. Then you have 1 magnesium, 1 magnesium. So it's balanced. It's compound with 2 things, reacting with compound with 2 things. So it is a double replacement. Next one, sodium is Na. So it's sodium hydroxide, which is OH, reacts with hydrogen sulfate. Sulfate is a polyatomic ion with a formula of SO4 and a charge of -2. That's on your reference table. I'm going to go ahead and put this charge there. To produce water, which we know is H2O, and sodium sulfate. All right, so sodium's charge is +1. It's in that first column. Hydroxide, we already looked up earlier. It's a -1 charge. That's from your reference table. Hydrogen is in column 1, so it's got a +1 charge. We don't have to check the formula for water because we know that it's H2O, so we don't have to check anything with it. Sodium is +1. Sulfate is -2. All right, so you've got a +1, -1. Those are balanced. You have a +1 and a -2, so you need 2 of these +1s to balance out that -2 charge. And then you have a +1 and a -2, so it's the same thing. We need 2 of those to balance out that charge of -2. So we're going to erase our charges, and then we're going to go back and balance it. So we have 2 sodiums here, so we're going to put a 2 here. All right, so that gave us 2 sodiums, 2 sodiums. We have 2 hydrogen, 2 hydrogen, but we also have 2 more hydrogen over here. So altogether we have 4 hydrogen, and then we have 2 oxygen. So if we put a 2 there, then that gives us 4 hydrogen, and we have 2 plus 2, and it gives us 2 oxygen, and that's 2 oxygen, so it's balanced. Okay, 4 and 5, I have a star by them because they kind of have stuff reversed. So it says water and potassium carbonate are produced from the reaction of potassium hydroxide and hydrogen carbonate. So you need to make sure that you pay attention to what it's saying. So it said the reaction of potassium hydroxide, potassium is K, hydroxide is OH, and hydrogen carbonate is on your reference table, CO3 with a -2 charge. And it said water and potassium carbonate were produced, so those are your products. So we know that water is H2O, potassium is K, carbonate we already looked up is CO3. So we have to check the charges. Potassium is in the first column, it has a +1 charge. Hydroxide is from your reference table, it's OH with a -1 charge. Hydrogen is in the first column, it has a +1 charge. So we're just going to transfer these charges on over here. So we have +1, -1. Those balanced out already. +1, -2. So we needed 2 hydrogen to balance out this -2 charge. And then we have +1, -2. So once again, we need a 2 right there. Let's erase the charges. So you got a compound with 2 things, potassium hydroxide, hydrogen carbonate. So they just switched endings, so that's a double replacement reaction. Now let's check and see if it's balanced. You have 2 potassium here and you have 1 here, so we're going to put a 2 there. We have 1 carbonate. So let's check. We have 2 plus 2, which is 4 hydrogen over there. So we're going to put a 2 in front of this side to make it 4. That also changed the number of oxygen to 2, which was 2 over here. Oh, and we didn't classify this as sodium hydroxide, hydrogen sulfate, compound with 2 things, double replacement. Last one, aluminum oxide is produced from the reaction of aluminum and sulfur. So it says aluminum and sulfur, and it gave S8 out from it. So that was the sulfur that was reacting. Produces aluminum oxide. So we know that's aluminum and oxygen. First thing, anytime we have a single element, check to see if it is a diatomic molecule. They start with nitrogen, end with iodine, and include hydrogen. So aluminum is not one of those, so it doesn't need a 2 subscript. Okay, so we got aluminum plus S8. It gave us that formula for S8, so we don't have to do anything with that. Now we're going to check the charges on aluminum oxide. Aluminum